You have seen some simple, straightforward truth tables. Let us now look at slightly involved truth tables. So, how does a truth table for not P and not Q look like? So, what do? P, Q, fill up the entries of P and Q, and then create not P, and then create not Q, so that it becomes easy for you to create the entries for not P and not Q. So what is not P now? P is 0 means not P will be 1, 1, 0, 0. And not Q column will be simply the negation of the Q column, which will be 1, 0, 1, 0. And now not P and not Q will be, and 1 and 1 will be 1, 1 and 0 will be 0, then again 0 and then 0. So 1, 0, 0, 1 will be the entries of not P and not Q. Well, how does the truth table for P and Q within brackets or not P look like? So how do we go about constructing this table? We need entries P, Q, not P, P and Q, and finally we need the answer P and Q or not P. So as you can see, 0, 0, 1, 1, 0, 1, 0, 1, not P will be 1, 1, 0, 0. Why? Obvious. P and Q will be 0, 0, 0, 1. Just verify. And P and Q or not P will simply be the OR of the third column here and the fourth column here, which will simply be 1, 1, 0, 1. Let us now write the truth table for P or R and Q. How does it look like? Now you have three variables, which means you should first write P, Q, R and flood the entries with all possible zeros and ones. So what do? P will have 4 zeros, 4 ones. Q will have 2 zeros, 2 ones, 2 zeros, 2 ones, and R will have alternate 0 and 1 like this. Correct? This is the way in which you write all possible 3-digit binary numbers, if you know what I mean. Think about it. Okay, so what is P or R? So P or R is this column or operated on this column, which will be 0, 0 or 0 is 0, 0 or 1 is 1, 0 or 0 is 0, and so on. And the rest will all be ones here in this column. And then what will be P or R and Q, the final column? It will be the AND of the Q column and this P or R column, which will be 0, 0, 0, 1, because it's 1 and 1, 1, 0, 0, 1 and 1.